Good evening, ma'am. Good evening. I'll wait for 2 more minutes. Let's others to join. Thank you. Bro, class வரலையா?
ப்ரோ நான் அந்த கிளாஸ்ல இருக்கேன் ப்ரோ, இன்னும் முடியல. நான் முடிச்சுட்டு வந்து ஜாயின் பண்ணிக்கிறேன்.
எங்க?
முடிச்சுட்டு நாலு முடிச்சுட்டு வந்து ஜாயின் பண்ணிக்கிறேன்.
ஓகே ஓகே.
ஓகே ப்ரோ.
Good evening, guys. If you have any doubt related to last week or first week session, you can ask now, or you can put it in the chat box. I will answer. We will wait for 2 more minutes. Yeah, hope you are enjoying the session. If you have any doubt or any comments, you can discuss with me. Okay, we will start the session. Good evening. Hope I am audible. Am I audible? Anyone please
Yes,
raise?
yes, sir,
Yeah,
yes, sir.
thank you so much. So I am Saravanan, Prime Minister Research Fellow and PhD Scholar at Department of Civil Engineering, National Institute of Technology, Tiruchirappalli, Tamil Nadu. So I am a PMRF scholar. So as a part of PMRF deliverable, I have to take 1 hour per week as a TA for other colleges in government polytechnic or any schools or in NPTEL. So as a part of PMRF deliverable, I am assisting this course, Municipal Solid Waste Management under Dr. Ajay Kalamdat sir. So last 2 weeks we have discussed about the basics of solid waste management and different functional elements of solid waste management. So as we all remember, first functional element is solid waste generation, then handling and storage, then primary collection, then secondary collection, transfer and transport, and then transformation, then finally it will be disposal. So out of this functional element, 6 functional element, we have discussed about how the waste was generated, how to handle, how to store, how to design the containers, and how much distance it should be, and how to primarily collect the waste. And this week we are going to discuss about some of the problems or analysis how to do secondary collection in terms of hall container and stationary container system. We have discussed about the basics of stationary container and hall container system in the last week. We are going to discuss some of the problems related to hall container and stationary container, and which one is suitable for which type of city or which type of places, and which will be cost effective, how to analyze which is effective in terms of cost, in terms of labor or manpower, that and all we are going to see today. So as a engineer, if somebody assigned you a work like which system is good for this many people, this much kilogram of waste generated per day, and this much collection frequency, and this is the container volume, and this is the truck I have provided to you, and um, like this is the manpower I have given, like 1 member crew or 2 member crew. Then how will you design which system you will select, hall container or stationary container, and what is the operational cost and what is the overhead cost associated with the two system. So after calculating all this, after analyzing everything, we can come to a conclusion which system is suitable for the particular region. So we can't say we can't generalize the system for a particular place. So it may be different from different location based on the distance, how much it should be transported from the location, generated location, to the disposal site or to the MRF facility. This distance also matters. So these are all we are going to discuss in this analysis session. Okay, so this formulas will be somewhat tricky. I have made one sheet with all the formulas that I will show you now. Please take a screenshot of that. We will discuss later. Okay, so can you please take a screenshot of this? I'll show you. So can you please just take a screenshot? So these are the formulas for hall container system. Yeah, please take a screenshot. We are going to discuss this only. Yeah, I'll move on to the next page. This is for stationary container system. These are all the whole formulas and descriptions. I'll share this file in this problem solving session tab. You can access later also. So as for today's calculation, you can take a screenshot. Yeah, and this is the combination comparison both in a single slide. Yeah, this is very useful for you. And then this is with the diagram and some of the tables we are going to use in the problems. And then final one problem for comparison, we are going to use this formulas. Yeah, I will share this file. I hope you all taken the screenshot. If you want, I will go again to the first slide. Is it okay? Can I continue? Hope you taken the screenshot. I will continue. Yeah. So please keep this file with you. We are going to discuss this only. So for Hall container system and stationary container system, what is the basic difference? As we mentioned, the container itself will be taken in the vehicle, and then it will be taken to the disposal site. It will be emptied and transported back to the original location. We will keep the container back. So this is called a haul container system. The container itself will be hauled. In stationary container system, we will only empty whatever the waste in the container to the vehicle, and then we will keep the container back in its original place at the same time itself. So the container won't be taken. Only the waste in the container will be hauled into the, taken into the vehicle, and the vehicle will be going to the disposal site. So this will be this is the basic difference between haul container and the stationary container system. So both will have in the both analysis we are going to discuss about the 4 unit operation. One is pickup, haul, at site, off route. So this is the basic of the whole analysis. So this analysis and the formulas are based on how much vehicle and the labor required, and what is the unit time required to perform each task. These are all combined in this 4 unit operation. So pickup, haul, at site, and off route. So what is first pickup? So you know this is the haul container system. From at the beginning of the day, the vehicle will come. It will take this container. It will go to the disposal site. It will empty the container. It will bring back the empty container, keep it in its place, and then move on to the next location. Like that, it will go up to the last location. It will go to its original place. The vehicle will go to the end. At the end of the daily routine, it will go to its original place. This is conventional mode. But it is in exchange container mode. First, at the beginning of the day, the vehicle will come. It will bring one empty container, and it will keep the empty container and take the full container. It will dispose in the disposal site, and it will go back to the second location. So we are eliminating this distance traveled between the sites. So that will be eliminated, and also one more trip to the disposal site also eliminated if you compare conventional mode and the exchange container mode. So this is the difference between these two in the haul container system itself. So here, what is first pickup? Pickup in the sense how much time required to take the container, and how much time required to keep the container back in its original place. That means empty container, and also that this time required to travel between one site to the second site. So this three summation will give you the pickup time. That HCS is haul container system. If it is SCS, that is stationary container system. So the notation will be same for all the both the systems, but only the H and the S will vary. Okay, so it will be easy if you understand the notations and the units. It will be easy to normal unit conversion only. So pickup include the sum of time required to pick up the container and unload the container, and also the time required to travel between the locations. So this three will give you the pickup time. Then second one is the haul time. Haul time is the distance traveled from the location to the disposal site, and the disposal site to again to the location. So this two will add you the haul time. So haul time is the time required to reach the location where the waste will be emptied, starting when the container has been loaded on the truck, continuing through the unloading until the truck arrives to the location where it is redisposed. So this two addition will give you the haul time. Okay, then so here another one you can see, it neither include actual pickup time of the load because pickup time will be included in PHCS. So here we are not including that time. Only the time traveled between the location to the disposal site is considered. Okay, that is the HCS, HCS. Yeah. Then at site time. At site time is the time we are taking at the disposal site to dispose the waste from the vehicle to the disposal site. That will give you the yes at site time. It's not on site, it's at site time. The time spent at the site, any disposal site, it may be landfill, it may be a MRF, or it may be a transfer station. Wherever we are taking time, that time will be included in at site time. So here in the whole analysis, time matters. How much time required, that will be directly converted to how much manpower required. So all are in terms of hours, per trip. Okay, the unit will be hour per trip. Yeah. Then finally, off route time. Off route time is somewhat miscellaneous, we can say. Totally, usually we will take 15% as off route time, which includes some of the non-productive activities like check-in, check-out, meetings, unavoidable congestion, traffic congestion. If we end up in some traffic, that will add time to the uh, travel, and then equipment repair maintenance if anything happens, and then some unnecessary. It will again, off route was divided into necessary and unnecessary. Necessary or this type of traffic congestion, check-in, check-out, meetings, weighing bridge, we will go and come out, that and all. Then unnecessary time in the sense some of the coffee breaks for the laborers and time spent for personal errands, this and all unnecessary time. So all will be added up to some of 15% of the total working hour in a day. So for a person or a labor uh, per day, the working time will be 8 hours. So out of which 15% was considered as off route. That means 8, 1 minus 0.5, you can see in the calculator I am showing you 8 into if you subtract point 15%, so you will get 6.8 hours as the working time for a labor in a day. I mean the productive working time. So 8 hours is the labor working hour in a day. Out of this, 15% was neglected as off route. So 6.8 hour is the working time for a labor. That's what we are going to consider for solid waste management analysis. So as we discussed, one trip uh, time required for per trip will be the summation of pickup time, on-site time, and the halt time. Okay, so this three will be the time per trip. You can see in the diagram. So time per trip will be this P, this H, and this S. This three will be added. So that will be the one time required per trip. And then you can go to the next trip. Like that, it will go to the next location. So in Hall container system, how much trip is equal to how much containers emptied. So this constitutes to one trip. Then if you are going to the second location, and then P will be there, again H will be there, again S will be there. So this three will be added as a next container or the next trip in Hall container system. So if you add up this 3P plus S plus H, that will give you the time per trip. So again, this P includes three conditions. One is pickup, unload, and time travel between the stations, as I mentioned. So this three will be added up to PHCS. So even if you are asked to find the time per trip, you have to add PHCS plus S plus H. In PHCS, it will be again the summation of three: time required to load, unload, and time required to travel between the locations. So this three added up give pickup time. Yeah, everything in terms of hour per trip. Okay, yeah. Again, there is one beautiful concept called this PHCS and the S is related in terms of rectangular hyperbola. So if you draw, because H in the sense, it is the distance between the, time required to travel between the location to the disposal site. So it is again based on how much distance and how much traffic, everything. So that is already plotted, and generally it will be in form of rectangular hyperbola. So if the distance is 0 kilometer or 5, in terms of miles, 0 miles or 5 miles or 10 miles per trip or 15 miles per trip, after 15 miles per trip it will become a saturated straight line. And the Hall speed, that is in terms of y. So if you are traveling into mile per hour, and the distance if you are plotted in x-axis and y-axis, you will get a rectangular hyperbola. Then the equation will be y equal to x by a plus bx. Again, h will be x by y. So the whole time h will be directly calculated in terms of a plus bx. So that's what we have calculated from here. So you can see h equal to x by y and y equal to x by a plus b. So if you substitute this in terms of x, then you will get h equal to a plus bx. So if you know the distance, you can easily find out the halt time, that is the h. So you can replace this h. That's what the halt time. So halt time will be based on how much speed we are traveling, how much distance we are going, and two constant. One is a and b. Okay, S will be easily find out how much time we are spending in the site that is given, and P we are getting from this formula. Okay, so we can easily find the time per trip for the Hall container system. Okay. Hope you understand this formulas for the Hall container system. And then number of trips. As I mentioned, one day we are working for 8 hours. That is length of work day. Out of which 15% we have to neglect. So usually it will be 15%. If they given any value, you can use that for the W. That is off route time. So this will give you total manpower time that is available minus T1 and T2. So T1 and T2 is the time required for the vehicle will come from the garage to the first location. I will show in the picture this beginning of daily route. So it will come from the garage to the first location, that will be your T1, and finally from the last location to the garage at the end of the daily route, that will be your T2. So whenever you have to design a system in this in a manner, the final route should be near the disposal site or the garages, or the first location should be near the garage, then T1 or T2 will be very negligible. Like that only you have to design any solid waste collection system. So this T1 and T2 will be also be calculated, time required to go to the first location and time required to leave the last location to the garage. So that also will be neglected, and uh, that also will be neglected, and then you will get the total time available in a day. Yeah. um, so anybody wants to ask anything? Sorry. Okay, so if you have any doubt, you can post it in the chat box. I'll answer, or if you have any doubt in between, you can ask, unmute, and you can ask. I will repeat, no issues. So we have 8 hours in a day, out of which 15% was neglected, and then we have to neglect the time taken to reach the first location, time taken from the last location to the garage also we have to neglect, and then the remaining available time divided by time taken for one trip, that is for one P plus H plus S, that will be the total time for one trip. Then we will get number of trips in a day. So that is the number of trips or number of containers collected in the Hall container system. So that is the whole analysis behind this. Okay, I hope you understand how to find number of trips or number of containers we can collect in Hall container system based on this analysis. Okay, so this all was given in one sheet, that is here you can see Hall container system. Trip per time per trip will be P plus S plus H. Then P again we can calculate by pickup, unload, and DBC. DBC is again in terms of A plus BX we can say, because this is also we have to travel from one location to another. That is in another constant. A and B are another constant, and X is the distance between the locations. And H is based on A plus B into X at the distance between the site and the location. Oh, this is the Hall. So this is the H. This is DBC. And the number of trips we can find by H into 1 minus W minus the summation of time required to travel, and then by time required for one trip. Then you will get number of trips. Okay. So the definitions on the unit you can see here. Okay. So we'll go to the problem. Sorry. So in the first problem, it is given round trip distance. Round trip distance in the sense, in the diagram if you see, location to the site and then site to the location, this is one round trip. One way trip is location to the site or site to the location. Round trip is location to the site and then back to the first location. There is one round trip. So they had given one round trip distance as X, and then Hall speed, the speed is 17 miles per hour if they are going, and the total time taking is 0.12. So that's the graph they had given. So we are asked to determine the Hall speed constants. So H, we know H is equal to A plus Bx. So A and B are the constant. That's what they are asking us to find. Hall speed constant. H is the Hall speed. Hall speed constants are A and B. So the following average speeds were obtained for various round trip distances. So various round trip distances are given, and the average speeds are obtained, and find the Hall speed constants A and B for a round trip and the round trip Hall time. For X equal to 11, what is the H? That's what. So first one by one we will go. But first, what is how to find A and B? So we have to plot this X and Y sorry, x and h in the graph. So as we mentioned, h equal to a plus bx. So you can see this is in terms of y equal to mx plus c. That is the equation of the straight line. So y equal to mx plus c. So y in terms of y axis h was there. So I have to write h in the y axis. So mx x in the terms x axis x you have to write in x axis, that is the distance, and the travel time, that is h in y axis. So m in the sense slope, so b equal to m, so slope we will be 0.02, that is your b, and then intercept c is a, 0.08 is your intercept, that will be your a. Okay, I hope you know the equation of the straight line y equal to mx plus c. So simply substitute h equal to a plus bx. So the slope is your b and the intercept will be your a. Okay, so simple calculation, you can easily get the Hall speed constants. And then another question they have asked. Now you know the a and b. So substitute in this equation, you will get h equal to 0.08 plus 0.02 x. And the another question what they ask, round trip halt time, that is h they are asking. Given that x equal to 11 miles for round trip. So total round trip they had given us 11. So you can simply substitute uh, evaluation of the round trip time, halt time. Site is located 11 meter away. Okay, so 11 miles is one distance they had given from the location to the site as 11 they had given. So again for the round trip we have to multiply into 2, or we have to add another 11 miles. So it will be total 22 miles. So you know here the total round trip distance is 22 miles. So x is 22. So you can substitute in the calculated equation. You will get the round trip halt time, that is h 0.52 hours per trip. Then if you divide this with the total time available in a day, then you will get how much location we can cover, or how much container we can empty, or how much trip we can round trip we can do in a day. So if it is in a week, you can multiply with 7. So simple calculation only. So here in this additional, what are the additional comment we are obtaining when determining the time required to travel? So how a equal to 0.08. So if you draw this graph x and y, sorry, x and h in x axis and y axis. So after plotting 2 and 0.12, so 2 comma 0.12 and then 5 comma 0.18. So if you plot all the points and if you join in terms of straight line, because this is in terms of y equal to mx plus c, the equation of straight line, and then connect that straight line with the y axis, wherever it is intercepting, that is called the that is the c value or the a value. So from the graph we are getting a equal to 0.08. Hope you got it. A equal to 0.08. And then the slope of this line, I think you know how to find the slope. Any 2 point you can take, and the distance between y axis and the dy by dx will be your slope. So slope will be 0.02. Hope you got it, Sarvesh sir.
So sorry for interrupting.
Yeah.
How a value is equals to 0.08? Can you explain that once?
So it is actually so you have to draw a graph with x in terms of x-axis and h in terms of y-axis. So 2 comma 0.12 your first point, 2 comma 0.12, and then 5 comma 0.18 is your second point. So if you are connecting all the points, and then the straight line will intersect with the y-axis, wherever it is intersecting, that will be your intercept, that is the a value. So it is intersecting at 0.08. You got it?
Yeah, actually, the point is starting from 0.08, not exactly from 0.1, right, sir?
If you zoom, you will get the answer. Yeah, it's 0.08, not 0.1. Or you can put it in Excel. You can easily find out. So just to draw this, plot this, just write this value in the cell, and you draw a line, and that will give you the a value and b value simply. Or in a graph sheet, you can draw. in Excel you can easily find. I hope you know how to draw, or I will show you once. So you can do 2, 5, 8, 12, 16, 20, 25. And then in the y-axis we are going to write the h value. So 0.18 and then 0.25, 0.33, 0.4, 0.48, 0.56. So if you draw a graph for this, so insert plot graph, scattered graph, and then you can form a trend line. So that trend line, if you show the linear trend line, show the intercept display, so you will get the answer. Excel to MX plus. So here you can see y equal to mx plus c. M is slope is 0.019 and this is 0.08. Hope you got it. Yeah, y equal to mx plus c. So this line will connect extend and it will connect with the 0.08. So that's the answer. So if you draw in graph also you will find. You got it?
Yes, sir.
Yeah. Okay. So this is simple calculation of y equal to mx plus c. Then what they asked round trip halt time. So again h they are asking. We already found the answer for h. So h equal to now what is h? H equal to a plus bx. So a is 0.08 plus b is 0.02. So b is 0.02 into x. So that is your value. So x you have to substitute. They given as 11 miles for the distance between this location to the site. For round trip we need to multiply with 2 and then you will get 22 miles per trip. If you substitute 22 in terms of x, you will get h value. H is what they are asking, round trip halt time. Okay. So the in that additional yeah, okay. So in the additional comment, we need to understand we are determining the time required to travel to the disposal site in the field. The time should be determined at the approximately the same time the collection vehicle will traveling to and from the unloading locations. So we have assumed 11 into 2. So we are assuming that the time the distance between the location to the site, if it will travel to the in the same speed, and the time taken to travel between the site to the location also will be the same. That's what the assumption we have taken. And the halt time data collected during working hours will include the effect of traffic congestion, weather condition, and so on. All this will be calculated in h value only. Okay, these are the additional comments. Okay. Then another problem they had given, solid waste from a new industrial park is to be collected on a large container drop box, some of which will be used in the conjunction with the stationary compactors. So in a large container they are storing the industrial waste, solid waste with some compaction machinery. Based on the traffic studies at the similar parks, it is estimated that the average time to drive from the garage to the first container location, that is the T1. As I mentioned, garage to the first location it will be T1 and the last container location to the garage will be T2. So T1 and T2 they had given us 15 minutes and 20 minutes. Okay, T1 is 15 minutes and then T2 is again 15 minutes, 20 minutes. Hope you got it. What is T1 and T2? And then what are they are asking us to find? If the average time required to drive between the containers. So drive between the containers, what is the notation? Drive between the containers. It is DBC. I mentioned you, right? Drive between the containers, it is DBC. Okay. So that's what they had given. DBC as 6 minutes. And one way distance to the disposal site. One way distance is X, 15.5 miles. If it is a round trip, then it will be 15.5 into 2. Okay, one way distance they are given, so X will be 15.5 into 2. And the speed limit is 88.5 km per hour. Determine the number of container that can be emptied per day based on 8 hours working day. So we have to find number of trip, or that will be equal to number of containers emptied, or number of location we have addressed. That's what we are going to find. Assume off route is 0.15. So our aim is to find number of trips. For that, the formula I have already mentioned to you. Number of trips or time per trip will number of trips will be nd equal to h into 1 minus w minus t1 plus t2 by time taken per trip. That was THCS, that means in the hall container system. So we have to find first THCS. THCS will be the summation of pickup time, on-site time and hall time, P plus S plus H. So H again we can find with the A plus BX. Pickup time we can find with the PC plus UC plus DBC. Yes, they are already given. Okay, so this is what we are going to find. Hope you got the formula. Yeah, so we have to first find PHCS. PHCS will be pickup plus unload plus DBC. So pickup time they not given, and unload time also they didn't given. So we are referring from a table. In that table, it is clearly mentioned if it is with the mechanical compactor, then we have to take the time required to pick up loaded container and to deposit. So both PC plus UC will be 0.4 hour per trip. So PC plus UC you can take as 0.4 hour per trip referred from this table. Okay, then DBC they had given us 6 minutes. And also please note down, everything will be in terms of hours, not minutes. So all units you have to convert to hours. So whatever minutes T1 and T2 and the DBC, everything you have to convert to hours. Then only it will be hour per trip. Yeah. So DBC was given as 6 minutes, that is 0.1 hour per trip. Then you can easily find the pickup time. Pickup time will be PC plus UC plus DBC. So 0.4 we already got, and 0.1 will be your 0.5 hours per trip. Okay. Then time per trip is pickup plus yes, on-site time, that is yes, plus A plus BX is what? H, hall time. That is also they mentioned in terms of A plus BX. So PHCS we already found as 0.5. Yes, we don't know. Yes, also we can find from this table. Outside time. Outside time is 0.133. We can refer from the table. And then A plus BX. How to find A plus BX? Again, we can refer this rectangular hyperbola. What is the A and B for the speed limit? So our speed limit is 55 miles per hour given in the question. So we can refer what is the A and B, that is a constant. So if you put P, S, and then A plus B, X is, as I mentioned, 15.5 miles is for one way. So if you are calculating for both the ways, that is a round trip, you have to multiply with the 2. So you can find time required for one trip as 1.21 hour per trip. So for one trip we need 1.21 hours. So we have in a day 8 hours, and then if you subtract 0.15, that is 8 minus 0.15, I mean 15% of 0.18, then again the time required to travel from the garage to the first location and the last location to the garage, that is T1 and T2 also, if you are subtracting, we are getting the total time as 6.8 minus 0.58. So the productive time available is 6.22 only, out of which one trip itself 1.21 hours. So if you divide 6.22 with 1.21, you are getting 5.14 trips in a day. We can't do 5.14 trips. We can't do any trips in decimals. So we are concluding as 5 trips in a day we can do. If you are collecting in this speed, and if you are collecting this much hours, you will get 5 trips in a day. Okay. Hope you got the answer. If you have any doubt, please ask. So this is about Hall container system. Yeah. Can I move on to the next question? So again, you can find the actual length of the work day because they already have 8 hours. Out of 8 hours, we found 5.14 trips per day, but we rounded off to 5 trips. Now, what is the actual length of the working day? So if you substitute 5 in ND and if you find H, that is the actual working hour, that is coming as 7.8 hours. So essentially, it's fine 8 hours. If it is very low, you can again add one trip. You can round it off 5 to 5.14 to 6 trips, and you can increase the efficiency by paying for the overtime charges for the labors. We can optimize the process. So this is the way we have to optimize the process. What is the additional comment? Where fractional equipment and labor equipment are obtained, the use of large container reduced collection frequency should be investigated. And if it is no round of no off route, I mean if no break or nothing was taken by the labors, then 0.15 can be neglected. So totally 8 hours can be utilized. So if you calculate like that, we are getting answer as 5.21. That again will be rounded off to 5 only. So it's okay to take off route time, no issues. But if you are subtracting the off route and getting a value of 5.8 or above, then it is good to round off to 6 and we have to neglect the off route. This is the way we have to calculate the Hall container system and optimization of the process. You got it? This point what I am saying is okay, because we got the answer as 5.14, we rounded off to 5. But if we got the answer as 5.8, then we have to round off to 6. For that, we have to subtract the off route and we have to make it as 6. Then we can easily optimize the process. So that's the answer we are getting here. Okay. So as of now, we have discussed about the Hall container system. Now we are going to discuss about the stationary container system. The same 4 unit operation we are going to consider: pickup, haul, at site, off route. Off route is again 0.15, I mean 15% of the total time. At site is the time taken at the disposal site. Here haul and pickup will change because you know what is stationary container system, and the vehicle will come. So here also T1 and T2 will be there. The time taken from by the vehicle to come from the garage to the first location, and the garage last location or disposal site to the final location, that is T1 and T2 will be there. But pickup time will be like we have to empty the first container into the vehicle and we are keeping the container back in its original place and going to the next location. And here the distance between, I mean travel time between each location will also be considered DBC. And then we have to empty the second container and the empty container will be placed back, and then we have to move on to the third location. Once the vehicle is full, we have to come to the disposal site. Here we can't conclude number of trips equal to number of containers. In Hall container system, it is easy to calculate how many trips is equal to how many containers emptied. But here it is not equal. Okay, so per trip will be maybe 4 or 5 locations or 6 location also. Once the vehicle is full, we have to come to the disposal site and then we have to go to the next trip or to the garage. Okay, so here pickup is like beginning with the stop to the first container and ending with the last container. So the whole process will be considered in this PSCC. This is a stationary container system. The same P, but a stationary container system. In Hall container system, we have considered only one location. How much pickup, how much unload, and then how much time taken to go to the next site. But here, one trip is equal to the whole thing. So time required to travel between n minus 1 site. If it is 4 locations, then 3 times we have to move. You understand? If it is 4 locations, we have to move 3 times. So n minus 1 times of the distance traveled and n times of hauling and taking and hauling. So that is the pickup time. Then what is the haul time? Here there is no need to go to the site and coming back for every location. This is only once we have to go to the disposal site. So haul will be at the end alone. Okay, at the end alone we are coming. So only one haul time will be here. So the whole formula will vary. So at site time it's same, off route time is also same as explained in the Hall container system. Okay, so here the PSESC will vary. The time required for one trip will be again pickup, on-site and haul. Again it will be same P. So always T equal to P plus S plus H. So this is the basic formula you have to always note down. Pickup, on-site and haul. This will vary based on Hall container system or stationary container system. In Hall container system, P Hall container system will be unload, load, unload, a distance traveled between. But in stationary container system, it will be varying as CT of UC plus as I mentioned, number of locations captured minus 1 into DBC. Okay, so this is also the number of locations into loading. Number of as I mentioned, if you are going to 4 locations, then 4 locations into time required for one location to empty the container. Okay, that is what 4 location into time required to unload, and then 4 minus 1 into distance traveled. That's what the pickup time. S will be same for both Hall container and stationary container. H is also same because in H we have to multiply the number of locations. Here only one H will be there. That is H equal to A plus BX. Okay, hope you understand this. If you have any doubt, please ask in the chat box or you can unmute and ask. Yeah. During problem also you will get some doubt and you can ask at that time also. Hope this is very clear to you. Yeah. So this is simple. In Hall container, basic formula is time per trip is pickup time, on-site time, haul time. Pickup time will be the summation of.
Yes, sir.
Yeah.
Imperial constant means what it will be calculating, sir.
Empirical constant in terms of A plus B. That is what we are calculated in the rectangular parabola thing only.
Okay, sir. Thank you.
Yeah, that's what the A and B. This A and B is to calculate H. Okay. Again, we can calculate DBC is also in terms of A plus BX. That X will be the distance between. So here X will be distance between the location to the disposal site. But DBC is the distance between one location to the another location. Here also you can do that A plus BX formula. That is the empirical formula. Okay. So I mean empirical constant and linear formula. Okay. So as I mentioned, pickup time for the stationary container system is number of location we have, number of container we have addressed into unloading time plus number of location we have addressed minus 1 into distance. Time taken to travel between the locations. Time taken to drive between the container locations. Okay. So there we have easily calculated the number of trips per day, but here we have to calculate in terms of number of trips per day equal to it is based on 1 second. Oh, நீ அவங்கள கொடுத்துட்டேனே நானு. Okay. Sorry for that. We will continue. Okay. So in stationary container system, the number of trips per day is based on what is the capacity of the vehicle. Because in Hall container system, the whole container was emptied. Taken to the disposal site. Here, only the waste in the container was taken into the vehicle and compacted. So if the vehicle is 10 meter cube and one container is having 1 meter cube of solid waste, then we can go up to 10 locations and take 10 containers and we will be emptied into the vehicle and compacted into 0.5 means then we can add again 10 containers. So 20 containers we can take based on the compaction ratio. That's what given in this formula. If the what is the number of trips per day is based on average daily quantity of waste collected. If it is 10 meter cube per day, then volume of the collection vehicle is 100 meter cube per day, and then compaction ratio is daily quantity generated is 100 meter cube, and the vehicle quantity is 10 meter cube, and then compaction ratio is 0.5. Then it will be, yeah, hello, Lakshmi ma'am, you want to ask anything? Okay, we'll continue. Okay, if the vehicle capacity is 10 meter cube and the compaction ratio is 0.5, we can go up to 20 meter cube. So 100 meter cube, we need 100 by 20, 5 trips we can do in a day with one vehicle. So that's the calculation we are doing. Okay, then time required per day, as I mentioned, has equal to, it is a whole day. It will be, so this is again the same ND formula. We have just replaced T1 plus T2 plus how many locations we have addressed or how many trips we have addressed into time required per trip. That is yeah, TSCS into ND whole divided by 1 minus W will give you time required per day. Then you can calculate how many manpowers we need to use. Okay. This is the same formula. We are just changing the modifying the uh, places. So I'll show you that whole sheet for the stationary container system. So here you can see. So the total time per trip will be pickup time plus on-site time plus A plus BX. It's a haul time. So here pickup time will be number of containers into unloading time, number of containers minus 1 into distance time required to travel between the containers. The number of trips per day will be uh, total generated quantity by quantity of the vehicle into compaction ratio. Okay, and then time required per day is total time between this T1 plus T2 and then number of trips into time per trip, then by 1 minus W will be the off route time. So if you divide everything, then you will get the time required per day. Yeah, here you can substitute TSCS with this formula, then you are getting this value. Okay, hope you got it. Yeah, we'll go to that. So if it is a manually loaded vehicle, 1 minute. Yeah, so if it is a manually loaded vehicle, the number of pickup location will be directly calculated with 60 into PSE and by TP. So PSE is also already we have calculated with the CT, this formula CTUC plus NP minus 1 into DBC. Then N will be your number of collectors, one people crew or two people, I mean labors, how many labors we are using, one people crew or two people crew, three people crew, by TP pickup time per location. Then that will give you number of pickup location in manually loaded vehicles. But this TP can be calculated again with the DBC plus K1 CN plus K2. If it is more than one person, then we can calculate with this formula. Or if it is a single person crew, then we can take from this table. For manual with one person crew, it can be easily taken up 0.5 or 0.6. 3 or more container means it will be 0.92. Okay, you can take from that. If more than one person crew, then you can use this formula. K1 and K2 are again constant, and CN is the average number of containers that will be given in your question. PRH, everything will be given in your question. You can easily calculate the TP value, that is pickup time. Then you can find number of pickup location for manually loaded collection vehicles. Yeah, hope you understand the stationary container system concept. We will go on to the problems. Yeah. So the question is for design a solid waste curb collection system to service a residential area with 1,000 single family dwellings. So we have to collect waste from 1,000 single family dwellings or houses. Okay. So two manually loaded collection systems are to be evaluated. One is a single loaded collection vehicle with one person, one vehicle with one person. Second option, one rear loaded vehicle with a two-person crew. So which one you are thinking which will be effective? I thought one vehicle with two person will be effective than one person with one vehicle. We will calculate and we will see the result. What is the size of the collection vehicle required and compare the labor requirement for each collection system. Yeah, these are the data given. Try to find what is the notation for the given data. Average number of residents per service, that is 3.5 number of residents in one service. I mean one house or one dwelling, 3.5 people are there, and then each person is generating 1.13 kg per capita. I have a doubt about. Uh, Sorry, you want to say something? Teja, sir.
Sir, I have a doubt. Is this a solid waste management class or some other class?
It's a solid waste only. What is that? What happened?
Is this solid waste management class only, no, sir?
Yeah.
Okay, sir. Continue. Because calculations are coming now. For that reason, I have a doubt, sir. For that reason, I asked. Sorry
Okay.
for
This
this. Yes.
actually system analysis will have problems and sums. So you have to go through this formulas actually.
Okay, sir.
Yeah. Okay. So I'll continue. So here it will be 3.5% in a house, and each people is generating 1.13 kg of waste per day, and then density of solid waste is 109 kg per meter cube. So this is very high. 1 kg per day itself very high per person. So container per service will be two 121 liter containers plus 1.5 cardboard containers, that is 75 liter of quantity. So we have two 121 liter container and 1.5 75 liter containers. Then collection frequency is once per week. That is the question given. And then collection vehicle compaction ratio is 2.5. Round trip haul distance. So whole distance they had given. The distance traveled from the container to the site, disposal site, again from the disposal site to the uh, collection final location, it's given 56 kilometers. So round trip they had given. The nominal length of the work hour is 8 hours, as we know Hutch is 8 hours. Then trips per day is given 2. ND is already given 2, or else we can find with the formula ND also. And then travel time is T1 they had given, T2 given, and then off route, as we know, 15% of the working hour. Then haul time constant is A and B, that is our empirical constant. Then at site, that is the S value they had given us 0.1. Average time spent driving between the containers. So one container to another container, it will take some time, that is DBC 0.72 hours. And then constant related to pickup time K1 and K2. This is to find TP, pickup time will be based on K1 and K2. Yeah. So what they are asking, to find the size of the collection vehicle required. So to find the size of the collection vehicle, yeah, that is the truck volume. The small v will give you the size of the collection vehicle. That is based on how much quantity we are generating by the compaction ratio. So that will be capital VP NP by R. So we need to, so R is given, that is the compaction ratio 2.5. We need to calculate VP and NP. So VP is calculated as volume of waste generated per week per location. So we know 1.13 kg of waste is generated and 3.5 people are there. Per week it will be into 7 divided by, so that will be in terms of kg. But container volume in terms of meter cube. So we have to divide it with the density. Density of waste is given 119. So we will get 0.233 meter cube. So that is your VP. But how to calculate NP? So NP I had shown the formula 60 PSC N by TP. So N is already given two trips per day, and we have to compare 3 trips per day. trips per day is actually 2 and 3. So we can easily substitute n as 2 and n as 3, and then PSC is common. PSC is pickup time will be your for stationary container system, pickup time will be calculated based on the whole working hour formula, h equal to T1 plus T2 plus ND into PSC plus on-site time plus all time, that is A plus BX by 1 minus W. So here everything is given except PSCS. So that will be calculated based on the whole H formula. So PSC is 2.32, and then 1 person crew TP is 0.92, that was taken from the table. And if it is a 2 person crew, TP can be calculated with the empirical formula. K1 and K2 are also given. PRH was not given, so we can take as 0. So TP is 1.35. Okay, that is the collection minute per location. So if you substitute the NP value that was calculated there, 151 and 206 location per trip, we can find the collection volume, I mean the vehicle volume required is 14 meter cube for 1 person crew. If it is a 2 person crew, 19 meter cube collection vehicle is required. That is the capacity of the vehicle required. That's what asked in the question. Size of the collection vehicle required. Okay, so I hope you understand how to find the size of the collection vehicle for stationary container system. Any doubt in collection vehicle capacity calculation? So here again I am showing the formula sheet. You can see here. So truck volume will be small v equal to capital VP NP by R. Sorry for today. So VP you can find how much volume of waste generated, NP through this formula, and R is given compaction ratio. So based on this we can find the truck volume. Then what else they are asking? To compare the labor requirement for each collection system. So first option they have provided a single vehicle with a single person. Second option is single vehicle with a 2 persons. So which will be effective? That what we are going to compare based on the labor requirement. Yeah. So if it is a 1 person crew to go to 1000 location, that what the 1000 houses it's given in a week. So per trip they are collecting 151 location. That what we have already found. Trips per day, 151 locations per day. So we need 6.62 trips in a week to collect from all the 1000 locations if it is a 1 person crew. The same we are calculating for the 2 person crew. We are calculating as 4.85 trips in a week to collect from all the 1000 locations. Here you can see if it is 1 person, we need 6.62 trip. If it is a 2 person, we need 4.85 trips. But if you are calculating the labor requirement, that is the TW, how much labor, I mean the collector day per week, that what we are calculating through this formula, normal H formula only, NW PSC plus TW S plus A plus B, A plus BX by H into 1 minus W into number of collectors only we are multiplying. So if it is a 1 collector or it's a 2 collector system, we are multiplying with that. Finally we are calculating as 3 collector day per week, and if it is a 2 person crew, we are getting 4.39 collector a day per week. So if you are comparing here, the labor requirement or the labor hour utilized for 2 person crew is more than the 1 person crew for the same 1000 houses. So if you compare this, we are utilizing more manpower to collect from the same number of households. So 1 person crew with 1 vehicle is optimized system to collect from 1000 households. That's what the conclusion we are giving here. So the labor requirement for 1 person crew is 25% less than the corresponding requirement for the 2 person collection crew. Okay, that's the conclusion. So if you compare in a table, 3.01 collected day per week, if it's a 2 person crew, it will be 4.39 collected day per week. Yeah. Another one problem was given. Design a solid waste curb collection system. Curb collection system is again a stationary collection system only. to service a residential area with 2000 single family dwellings. Manually loaded collection system is used, which involves a real loaded vehicle with a 2-person crew. That is the question itself given, one vehicle with the 2 persons. But what we are changing here is ND is 3 and ND is 3. Sorry, 2 and 3. That's what we are going to compare the labor requirement for trips per day if we are changing. Yeah. So if we are going 2 trips in a day, what is the collection vehicle capacity required? If we are going 3 trips in a day, what is the size of the collection vehicle required? And how much labor required for both the cases? Yeah. So as you know, how to find the truck volume, small v equal to capital VP NP by R. R was given as 3, that is the compaction ratio, and then NP we are going to find and VP we are going to find. VP is the total volume of the waste collected. That is given 1.145 kg per day, and then density also given, number of residents also given. So we can find total volume of waste per location by multiplying with the 7 will give you how much waste generated in a week in a location. Simple unit conversion only you can easily find. So if it is kg per person per day, if you multiply with the person per location, person will get cancelled. And then if you multiply with 7 days per week, it will become week. So simple unit conversion only. You can find the volume per week per location. That is VP. So 0.256 is common for both the cases, and then R is also 3 for both the cases. Only NP we are going to find. So NP is 60 PSCN by TP. Here 60 is common. TP we need to find. N is 2. 2 in the sense number of persons in a crew. 2 people crew, both are 2 people crew only. Only PSC and TP we need to find. Yeah. So how to find TP? TP is more than 1 person crew. We have to use the formula DBC plus empirical formula K1, K2, CN, PRH. Everything was given in the question, so we can easily substitute and find the TP value. For finding pickup time for the stationary container system, we can use the normal total formula, that is such formula. We can rewrite and we can find this equation. So this is not this different formula, the same H formula we are using to find the PSC. In that we are simply substituting ND equal to 2 and another one ND equal to 3. We are getting 2 PSC value. The 2 PSC value we are substituting in to find NP. That NP we are substituting to find the truck volume calculation. So if it is 2 trip per day, we need 16 meter cube collection vehicle. If it is a 3 trip per day, we only need 9 meter cube collection vehicle. That's the conclusion we are getting. Once again. Yeah, that's the difference you are getting for 2 trip in a day, and yeah, that's the difference you are getting in 2 trip per day and 3 trip per day. How much container capacity you need? That is 16 meter cube truck and 9 meter cube truck. Then second question they asked us to compare the labor required if it is a 2 trip and the 3 trip. So for labor requirement calculation, again we need to use the same formula, number of collector into NW PSC TW S plus A plus BX by H into 1 minus W. H is always 8, W is always 0.15, A plus BX is given in the question, and the on-site time also 0.16 is common for both the thing. X is one-way trip or two-way trip, you have to find out. If it is two-way trip, you can directly substitute. If it is one-way trip, you have to multiply with 2. So it's common for both the cases. And then TW is the trip per day. So for 2 trips per day, what we are getting is NW as for 1000 dwellings are. But in this question, it's given as 2000. It's actually a calculation mistake. If we make it as 1000 trips by 190 locations we are finding in a trip. So we need 5.26 trip per week. In this, if it is a 3 trip per day, we need 9.8 trips per week to collect from all the 1,000 houses. So 5.26 and 9.8 is the NW we are going to substitute. 5.26 and 9.8. That's the time required. Sorry, trip required in a week into per how much hour required per trip. That is PSC we have already calculated as 2.22 and 1.2. If you work out it once, you can easily find out the formula or logic behind this. TW is the rounded off value of NW. Although we are collecting 5.2 trips or 9.8 trips, the time requirement calculation is for the whole, I mean the rounded off value only. So 6 and 10 will be the rounded off value. For that you are multiplying and getting the result as 4.9 collected day, here 5.9 collected day. So if you compare this, if you are going for 3 trips in a day, it will be more labor requirement. If so, better to go with one vehicle and 2 trips per day will be your effective way of collection for 1,000 households. That's what the comparison table given. So if it is a 2 trip per day and you are collecting 190 location in a trip, if it is a 3 trip per day, you can collect 1 or 2 location per trip. So here comes the problem. You can only collect 1 or 2 locations per trip, but here we are collecting 190 trips, and but with a bigger vehicle, that is 16 meter cube. Here a smaller vehicle, that is 9 meter cube. That's what we have calculated. And then finally the labor requirement will be 4.9 collected day. Here 5.9 collected day. Yeah. So now we have understood how to analyze Hall container system and how to analyze the stationary container system. Now we are going to compare both Hall container and the stationary container system. So this problem is to relate both the systems. So in the system, the problem statement, if you read, a private solid waste collector wishes to locate a MRF near the commercial area. So he wants to construct a material recovery facility for a commercial area. So here, a private waste collector want to construct a material recovery facility near a commercial area. So he want to analyze which system is suitable for the case. So it may be a Hall container system or a stationary container system. But where he want to construct the MRF should be cost effective. So he want to find the distance, that is the X, how much mile away from that we have to note down, we have to calculate. For that, the Hall container system should be cost effective than the stationary container system. That's what we are going to find. In the question itself, they have mentioned that the T1 and T2 are included in the off factor, so no need of T1 and T2. And assume that one collector driven vehicle which will be used in the system. I mean both Hall container and the stationary container system. All the data were given for Hall and stationary container systems. So only we are going to find the X value with which the Hall container should be less than the stationary container system, up to which, yeah. So to determine, to analyze the Hall container system, first we need to find the number of trips per week. For that, we know the quantity of waste, and then we know the average container size and the container factor. If you divide the waste generated by the container size and the container utilization factor, you will get 57 trips per week in a Hall container system. And then we know pickup time is the time required to pick up, unload, and the travel time. So that will be PC plus UC plus A plus BX. So PC and UC you can get from the question. It's given as 0.33, but it's actually 0.033. Kindly correct it. 0.033 for both PC and UC, and A plus BX is given in the question itself. Between the locations A and B is 0.06 and 0.042, and the distance is 0.16. That's what substituted. So we are getting PHCS. So that PHCS we are taking into time required per week formula. We are getting time required in terms of X because we don't know what is X. That A plus BX is different for DBC. This A plus BX is different for H. So please don't confuse with this empirical formula. A plus BX will play both in DBC calculation and also in H calculation. So this is simply PS plus H formula. Okay. So this X we need to find out.
So TW we have analyzed in terms of X. Then they already also given the cost incurred in the operation and the overhead cost. So overhead cost is simply the addition, and the operation cost is based on how much hour we are operating. So operation cost is how much hour we are operating into the operation cost per hour into time required per week. That's what TW. So TW as it is with the X we are substituting. We know 8 hours we are working in a day into the cost per hour. So we are getting the operation cost in terms of X plus the overhead charge will give you the total cost, because we need to add the overhead charge for the hall container system. The same procedure we are following for the stationary container system. This is for the hall container system. We are simply substituting the same for the stationary container system, and we are finding the total cost, and equating this two will give you the X value up to which the both container system will have same cost. Above that, hall container system will be higher, stationary container system will be lower. Okay, that's what the substitution. Simple CT formula. Again, PSC we are calculating, but the formula is different. Then NW we are calculating. That NW we are substituting in TW formula. In terms of X we are getting that, again we are substituting in the operational cost formula. Yeah, that operation cost will be added with the overhead charge to find the total cost. Yeah, total cost will be in terms of X. So if you assume any value for X like 0 miles, 1 mile, 2 mile, 5 mile, 10, 15, 20, like that, if you assume some values, we are getting the total cost for both hall container and the stationary container system. So here if you see up to here 58,000, here 65,000, here 63, 66. About 20 miles, if you are going to 25 miles, it is 68 and 66. So hall container system exceeding the value of stationary container system. If you plot this in the graph, you can see up to 20 miles or 20 kilometer, we are getting value less than a stationary container system. But if you are going about 20 miles, then stationary container system will be good. Hall container system will be costlier. So I can advise the private agency to construct a material recovery facility within 20 kilometer. Then the hall container system will be cheaper than the stationary container system. That's what the answer. So instead of plotting in a graph or a trial and error, you can simply, an alternate way will be the stationary container system equal to the hall container system. You will get the X value as 22.84 kilometer. Yeah, that is the intersect value, 22.84 kilometer. So one way distance will be 11.5 kilometer. So we have to construct at 11.5 kilometer. Then the hall container system will be cost effective. Okay, hope you understand about how to collect and which system will be effective in which case, that and all we are we understand up to now. Then collection routes. This is again a simple design by trial and error approach. This collection, if we are given with a map of Chennai, one location. Chennai is having maybe 100 wards. So one ward we have to collect waste. One ward maybe 1,000 or 2,000 households. With each house will have 3 people generating 1 kg of waste per day. So I have a vehicle and a 2-person crew. Which route I can follow to collect from all the households without touching again in the same household? It means again it is waste of time. So I need to collect from all the households, but the route should be in an optimized way. Like that we have to design. So it's based on the crew size, vehicle, and the route should be begin and end near the arteries. Arteries is the major roads. That is like a main road. If the route starts and end at the main road, then it is easy to carry the waste to the disposal site. And topography and the physical boundary are all should be considered to design the collection route. Once again. Yeah, sorry for that. So another approach is work down the hill. So you have to start from the top of the hill and we have to collect down the hill. It will be easier to dispose the loaded vehicle at the bottom of the hill. If you start from the bottom of the hill and collect, then you will have the full loaded truck at the top of the hill. So this is another approach, work down the hill. So the last collection point should near the disposal site. It is again easier because if you collect from the last location, your vehicle will be full, and if it is near the disposal site, it is easy to go and dispose the a full container. Yeah. Extremely large load should be dealt with early in the morning. Again, it will if you are collecting, the route should be, I mean, the time of collection should be early morning, before 8 o'clock or before 7 o'clock. The collection should be finished. It should start from 6 o'clock and it should end with 8 o'clock. Otherwise, a traffic congestion because of school people and office people will cause some irritation or traffic congestion, and some leachate will also fall from the collection vehicle. It will create pollution, or it will contaminate the routes. So it's good to collect early in the morning. Yeah. So here we are given with a problem how to draw a route for this. You can consider this as a ward. So here we are having different households or apartments. These are all number of blocks. I mean, here 2 houses are there. Here in this apartment 6 houses are there. In this road 2 houses are there. In this facing 6 houses are there. Like that, number of houses are given or residents are given in each blocks. The question is, the service area map would be prepared as the first step in the layout of the collection route. Assume the following conditions apply. So each residence will have 3 people. Each people are generating 1.6 kg per capita, and collection is 1 week per day. So sorry, once in a week. So once in a 7 days only they are collecting from each household. That's what given. And the type of collection service is curb collection only. So people have to dispose in the curb, or it will be a door-to-door collection. And then collection crew is 1 person with 1 vehicle of 10.7 meter cube capacity. That is the vehicle capacity. So if I multiply the waste generated divided by the vehicle capacity, I know how many route I have to, I mean how many trips I have to do. Yeah. Then compaction, specific compacted density of the waste is 320 kg per meter cube, because it's a fresh waste. It's containing 320 kg per meter cube of density. And a major thumb rule for designing the collection route, or this is no U-turn should be there in the streets, because with the heavily loaded truck or vehicle we can't do any U-turn in the street. So no U-turns are allowed. And then collection from each side of the street with stand-up right-hand drive collection. So whenever I am going, I have to collect on my right side. It will be easier to collect. Then it is easy to collect in all the locations. These 2 are the thumb rules we should follow. No U-turn, and the collection from each side of the street with stand-up right-hand drive collection system. Yeah. So as given in the question, we have this many residents. So if you multiply this 6 plus 6 plus 2 plus 2, it will be 12 plus 4, 16. Here 16 residents, 10 number of 16 residents, and 4 number of 36 residents, and 1 number of 28 residents were there in a ward. We have to design. So totally 332 residents we need to design the collection route. So if it is 332 residents, into 3.5% in a residence, into 1.6 kg they are producing, into 7 days, because 7 days once only we are collecting. So we need to calculate total quantity divided by the density will give you the total meter cube of waste generated. So volume of waste generated per week is 40 meter cube. Then this total weight divided by my collection vehicle is 10.7 meter cube only. So I need 3.8 trips. So we can't do 3.8. So it will be a total of 4 trips. Okay. So rounded up as 4 trips. So I need to do 4 trips to collect the whole waste from the residence. Yeah. So if I want to collect from the whole 4 residents, total number of residents is 322. So divided by 4 will be 83. So I need to consider 4 routes. Each route should touch 83 residents. Like that I have to do. No U-turn should be there. And it will be on the right side whenever the collection was considered. So the first route starts from here, and it will collect all this, and then again it's going on the same side. So it is waste of time. because already I have collected from this 6 residents. Why I have to go to the same site? And then I am coming through this way and then collecting from all this 4 side, and then this residence, this block I am going and collecting from all the residents. But this is again a waste of time. Collecting from this side and then this side, whatever the dotted lines given are all waste of time, because 2 times we are going to the same location in a week. That is again waste of time, or it will collect extra load. Whatever they are generated in the meantime, they will again unload into the vehicle. So it will add extra work to the collection vehicle. So we need to design route in such a way to collect from all the residents in 4 trips. Each trip should be collecting 83 residents. Like that, we need to figure out a diagram. Okay. So additional comment is the effectiveness of collection route can be assessed by the amount of route overlap. So this is the main thing. Overlap should not be there. Like whatever the dotted lines are all overlap. Already collected here, here also already collected. 2 times we are coming on the same route. So this is again waste of time. So we can do trial and error to connect. Some of the softwares are also available to optimize the routes. Some algorithms are there like ant colony algorithms, and some of the modern AI techniques are there to optimize this type of municipal solid waste collection routes. So you can go through some of the literatures. I will also upload some literatures in the problem solving session. You can go through. Yeah. So final module we are discussing about the transfer stations. So in the first week we have discussed about the waste generation, and the second week we have discussed about the waste handling and the storage, and this week we have discussed about the collection and analysis of collection systems, primary and second collection system, and then we are going into the transfer and transport, out of which transfer station we are going to discuss in this module. So why we need transfer station and what is transfer station? So whenever waste is collected, it can go to the disposal facility or any MRF facility. But in between, why we need any transfer station? Because if you see the satellite view of Guwahati, disposal site is actually very far from the city. So if you consider any hall container system or a stationary container system, the transport of vehicle itself will require a lot of energy and manpower or fuel cost. Again, operation cost will be increased. So we need a intermediate facility to unload all the waste, and from the facility a bigger vehicle will come and take the waste to the disposal site. So this will reduce the operation cost, and this will also again so this will reduce the operational cost, and this will again optimize the process. The hall container system will again, it will be cheaper if it is collecting waste from the transfer station to the disposal site instead of collecting from the generated location to the disposal site. Okay. And again I am mentioning collection is the costliest part of solid waste management. If you are allocating 1 crore for solid waste management, 80 to 90 lakh will only go to collection and transport itself. So we need to optimize this process. For that we are constructing a transfer station in between the generation point and the disposal site to optimize or to reduce the collection and transport cost. Here you can see in San Diego, $33 million were used only to haul the trash. Haul means to take or to transport. So it's not the economical solution. For that, transport station comes into picture. It's a processing site. It's like a simple room or a location where the waste will be unloaded from smaller vehicles and deposited, where we can recover some of the recyclable items, or we can also segregate the waste and we can dump or compact into the bigger vehicle to the disposal site. Yeah, that's what mentioned here. Transfer and transport in the solid waste management refers to facility and apertures used to effect for transfer operations. There is a necessary when the haul's distance to available processing sites are higher. Whatever the MRF facility or any landfills are very far from the location, then we can have a transfer station. And then processing centers and disposal sites are in remote location and cannot be reached directly from the highways. In that means also we can easily construct a transfer station. Yeah. So use of smaller vehicle for collection will not be effective to transport up to the disposal point. For that, we need a transfer station to unload the waste and then to load into a bigger vehicles. Yeah. So we can also use a pneumatic or a hydraulic press system to to load the waste from the transfer station to the larger vehicles. Here you can see how the waste was processed, and we can use the transfer station as a recycling center also, like a MRF facility. We can recover whatever recyclables or whatever recoverable kind of plastics, glasses, metals, that and all we can recover, and only the waste that could be disposed will be sent to the disposal site. So if the collection point is here and disposal site is here, we can make a transfer station, and that can remaining things will go to the disposal point. One part of waste will go to MRF, and one biodegradable will go to the compost point. So this all will be like optimization of solid waste management process. So instead of sending 100 kg of waste to the landfill, we are sending only the inert material or 50% of the unusable material to the disposal point. So here again we are having three types of transfer station. One is direct load, one is storage load, and combined direct and discharge load. When a smaller vehicle emptying its waste directly to the bigger vehicle, then it is called a direct load. When the vehicle is emptying in a platform, then from the platform if it is directed to the bigger vehicle, then it is called a storage load transfer station. Combined in the sense, some vehicle may directly transfer, some may dispose, and it will be whatever recoverable can be recovered, then it is transferred to the bigger vehicle, and it is called combined direct load and discharge load transfer stations. It is like a multi-purpose facility. So you can also see some of the pictures here. Direct load means the smaller vehicle, that is the incoming vehicle, that is dumping all the waste and compacted with the bigger containers. Or we can also use this type of pipelines, that is called compactors. This will compact, and the whole pipe will be tilted into the bigger containers. It can be transported. If it is a storage transfer station, we need a platform there. Every smaller vehicle will empty the waste, that will be recovered, whatever recoverables, then it will be transferred to the biggest locations, bigger containers. Then it is a combined. So you can see some of the pictures. And what is the advantage of the transfer station? It will lower the collection cost and reduce the fuel and maintenance cost, and increase the flexibility in selecting disposal facilities. So whatever the option we could recover, and finally which could we can divert waste. Biodegradable may go to compost, and recyclable may go to MRF, and hazardous waste may go to landfill. Like that, we can have a flexibility to select disposal facilities for different kinds of waste. That will reduce again the load to the landfills. And then option to separate and recover recyclables or compostable, and we can also shred and bale the waste. So that will again reduce the volume of the waste. But the disadvantages is difficulty with the siting and permitting. People won't allow for the construction of transfer station in their premises. We can't construct any transfer station inside the city premises. So it will again there is a problem with locating the locating a site for the transfer station. Then construction and operation cost will again add to the solid waste management cost. These are all some of the disadvantages related to transfer stations. Hope you all understand. If you have any doubt, please put it in the chat box, or you can unmute and you can ask. Or else we can go to the problem solving session today. Simple problems. I'll give you formulas also. You can also work out easily. So any doubt, you can post it in the chat box. Yeah. So I'll move on to the questions. If you have please answer it in the chat box. A, B, C, D, like that. I'll read out the question. Which of the following is not a unit operation of collection system? So we have discussed 4 unit operation of collection system. which is not a unit operation. Pick up, haul, on-site, off-route. So you can put the answers in the chat box. Yeah. So we have discussed 4 unit operations. One is pick up, haul, at site, off route. So at site is correct. So here on site is wrong. Yeah. Great. So 4 unit operations are pick up, haul, at site, and off route. Yeah. Thank you. So next question. In waste collection system, haul container system includes. So we have 3 times. One is pickup time, one is haul time, one is on-site time, and off-route time also. But in the haul container system, the hatch represent what are the following things: time required to reach the location where the waste will be emptied, actual picking up of the loaded container, redeposition of the empty container, time spent at the location where the waste is unloaded. Yeah, correct. So option A is correct. Time required to reach the location where the waste will be emptied. That should be multiplied with 2 again, because that is one-way route. If you want to find two-way or round trip, then you have to multiply the distance with 2. Okay, you understand the concept. Can you mention what is B, C, and D? Actual picking up time, redeposition time, and time spent at the location. If you add up these 3, what will be that? Can you answer this for haul container system? If you add up actual picking up time, redeposition time, and time spent at the location, that will be your pickup time. PHCS it will be. Okay. So the answer is first one. So pickup time, unloading time, and travel time will give you the pickup time, total pickup time. The distance, travel time between the location to the disposal site will give you the haul time. Okay. Yeah. So the third question is, in waste collection system, off-route collection system includes. What is off-route? Redeposition of empty container, time spent at the site, actual picking up of the loaded container, time spent on all non-productive activities. Yeah. So the answer is time spent on all non-productive activities. That's correct. So off-route time will be 15% of 1 day's productivity. That is 8 hours left. 15% we have to deduct as a non-productive for our non-productive activity. It may include necessary and unnecessary activities as we have discussed. Yeah, you can refer here. So following following 7 questions are based on this given data only. So it's given haul container and stationary container data and location characteristics. So they are asking estimate the average pickup time for the haul container system. So can you tell the formula for pickup time? Pickup time for haul container system. So pickup time will be time required to pick up PC, pick up the container and unload the container. Then time required to travel between the stations, between the locations, that is DBC. So here in the question, if you see, it's given as, actually it's 0.033. Kindly change this, 0.033. So container pickup time is 0.033 and the unloading time is again 0.033. And DBC, that is distance traveled between the containers, that is 0.16 kilometer. A and B also given, so you can substitute A plus BX. Again A plus BX will come for H also. That A and B are different. This A and B and X are different. Okay, so here you can substitute 0.16 kilometer, and A and B are given as 0.060 and 0.042. You can substitute and tell the answer. I hope you understand what is the pickup time, pickup, unload, and the distance travel. I mean time required to travel between the stations. So the answer is C. Yeah? No, the answer is A. Can you please check your answers, sir? 0.113. This is the formula we are using. 0.331. Okay, I will calculate once. So this is 0.3033 plus 0.033 plus A plus BX. A is 0.060 plus B into X. B is 0.042 into X is 0.16 kilometer. Answer is 0.133. That is correct. 0.133. Can you please check? This is the calculation. Can you please check? Yeah. Okay. So answer is 0.113. Right? That is correct, right? 0.113. Okay. So next question is same data. The question is estimate the time required per week as a function of round trip haul distance. So function of haul trip distance is x. So we need answer in terms of x for hauled container system. So for hauled container system, what is the formula for TW? So can you go to the same PDF? So TW is equal to for hauled container system. NW PHCS plus S plus A plus BX by H into 1 minus W. So H is 8, W is 0.15, NW is number of trips required. For that, we can calculate from the total quantity of waste by average container size and container utilization factor. Everything was given in the question. And then PHCS we have calculated now only. Plus S. S is on-site time that is given. Then this A plus BX is based on the H value. So that A plus BX you can see. Sorry. A plus BX, a haul container system. This A and this B is the A and B, and then X in terms of X only we need. So you can find TW in terms of X. Hope you understand the formula. NW into P SCS, sorry, HCS by H into 1 minus W plus S plus A plus BX. Simple formula. You can actually this is P plus S plus H only. H in terms of A plus BX they are given. Okay. So everything in terms of X we will find. So NW you can find with the how much waste generated. So waste quantity 230. Then we know the compaction factor and the size of the container. 230 by 6 into 0.67. I mean container utilization factor, not the compaction factor. Container utilization. In 6 meter cube of container, we are only using 0.6. That is 60% of the container we are using. Other 40% we are not having any waste. So 6 into 0.67. 230 divided by this value will give you the total quantity of the waste. That is your NW. Simple value. So if you calculate, you will get 1.74 plus 0.12x. Are you getting? Are you getting anyone? Any doubts? Gupta sir, are you getting?
Sir, in a question, two values of A and B.
That's what, ma'am. So we know uh, P plus S plus H is our total time per trip, right? Total time per Hall container system. So this H we are finding in terms of A plus Bx, that is our rectangular hyperbola we have discussed, remember. So this is the A plus Bx. This distance is Hall distance, one location to the disposal site location. So this is our H. So that X we are getting from this formula. The same formula A plus Bx we can apply for one location to another location. The small dBc also we can find with the same A plus Bx formula. For that we need to use that A, that B, and the distance between two locations. So in question if you see, location characteristics was given. For that, location between the container is X, A and B.
Okay.
This is Hall time constant. Hall is location to the site, that is H. So in that, for H calculation, A, B, X. X we don't know. That's what they are asking.
Okay, sir.
So everything is travel in terms of speed only. So one location to another location also, based on speed we have hyperbolic formula. Location to disposal site also, based on speed we have hyperbolic formula. So they have assessed many different speeds and different distance, and they have come up with this constants, ma'am. Okay. So if it is given as location characteristics, we can use that for dBc calculation. If it is given as Hall time constant, we have to use that for H calculation. Can you calculate? Is it coming as 1.74 plus 0.12 x? So the question they are asking in terms of x only, because x is not given. Okay. Hope you got the answer. We will move on to the next question. Okay. So the same data they are asking, estimate the weekly operation cost in terms of again x only. We don't know x, so we can substitute in the terms of same x. So how to find the weekly operation cost? So we know the formula. I'll show you the formula. So operation cost equal to operation cost per hour. We know one day how much time we are working, 8 hours per day, and then time required per week. If you multiply everything, we will find the operation cost. So operation cost per hour they are given. 8 hours in a day we know. Time required per week we have to find. That is the TW. We already found TW. That is the last question answer. Yeah. So if you multiply this 1.74.12x, 1.74 plus 0.12x, that is your number of trips in a week, into we have 8 hours in a day, into per operation cost per hour is 1067 rupees. 1067. If you multiply, you will get the answer in terms of rupees. That is the operation cost. So I hope you will get this answer. A. Are you getting? So if you multiply 8 into 1067 into 1.74. So first itself we will get the answer 852.64. Sorry, it is 852. Typing error. And then again 8 into 1067 into 0.12 will be 1024.32x. Hope you got the answer. Is it okay?
Yes, sir.
Okay, we'll move on to the next question. The answer is, the whole formula is this, and TW we already found. So operation cost is given in the question. Daily time 8 hours, that we know. So if we multiply, we will get the answer. This is what the question we have discussed in the class also. Simple. Yeah, the same data we are using for the yeah.
Sir, all the formula we have to remember?
I don't think so. Like in the exam, they might have provide these formulas, but it's actually the unit calculation. You know, don't need to memorize the formula. You can choose any notation and you can multiply.
Okay.
Please go through the
Okay.
formula once. You will understand, and you can put any notation on your own that you can write and note it down. I mean, use it for the upcoming calculations.
Okay, sir.
Or I will provide you one formula sheet that you can easy to memorize. I will provide you at the end of the course at the 12th week. Okay. So this question they are asking about number of containers emptied per trip. So number of container emptied per trip, we know the formula. Again, it is about the stationary container system they are asking. Number of containers emptied per trip is equal to, we know the volume of collection vehicle, compaction ratio, container volume, container utilization factor. VR by CF will give you the number of containers emptied per day. So, can you calculate, the formula is volume of the collection vehicle, that is in the stationary container system 23, compaction ratio is 2 divided by 6 into 0.67. So if you calculate everything, 6 into 0.67 and 23 into 2, volume of the vehicle into compaction ratio is 2. So I can easily find the number of containers. Is it coming 11? 23 into 2 divided by 6 divided by 0.67. Yeah, 11.44 number of containers we can empty, but we can't empty 4.44. So rounded off value is 11 containers we can empty. Okay, the answer is CA. You are getting. I'll move on to the next question. The same data, they're asking the pickup time per container for stationary container system. For Hall container system, we know PHCS is UC plus DC plus, UC plus PC plus DBC. That is the distance between the containers. Why they are using DBC, distance between containers? PC is pickup time for container. UC is unloading time for container. So you can use any notation, you can easily mark up. So UCPC, that and all very hectic to mock up, but you can use any notation. But if you know the meaning, you can easily understand. If it is a pickup time for stationary container system PSCC, then the formula is CTUC. That is a number of containers we are locations, one location, two location, three location, like that. How many location we are going into time per location. That notation is UC, unloading time per location, plus if we are going to 3 location, then 1 and 2 distance we are traveling. Okay, so CT minus 1, that is NP minus 1, number of location minus 1 into the distance time DBC. That's what the formula. Okay, so if you multiply, you will get the answer. So they given the number of locations. No, then CT also we need to find out. Once again, we have to find the CT. CT we have calculated. Okay. In the last question we have calculated 11. 11 is the CT answer. So 11 into 11 containers we are going to do. UC we know 0.033 or container time for unloading the container 0.5 hours per container. So 0.5 plus, if you are going to 11 container location, we need to travel 10 times of the distance between the containers. Already we have calculated the DBC with this location characteristics is common, A, B, C, X are common. So already we have calculated the DBC as 0.16. So that you can use 0.16 we can use. So we can get the value 11 into 0.5 plus 10 into 0.16. What is the value? 11 into 0.5 plus 10 into 0.16. So answer is 7.1. Sorry, is that a 0.16? 11 into 0.05. Sorry, it's 0.05. 10 into 0.0067. Please note down the DBC value. A plus bx, you can find 0.06672. Here 0.05. That you can multiply and you will get the value. That is 1.22 hours per trip. Okay. You got the answer? So it's easy. 11. Here 10. UC is 0.05. Here A plus bx we have already calculated for the hall container, because location wise it's same only. Yeah. So the same question they are asking, number of trips required per week. So for number of trips required per week, the formula is NW. Number of trips required per week. How much quantity we are getting by container size and container installation factor, simply we will get. So the answer, question it's given. Weekly quantity of waste collected is 230 into how many people and how many, that is directly given, 230 meter cube per week, directly given. Quantity of waste collected per week divided by average container size is 6 meter cube and the compaction ratio is 2. Sorry, container utilization factor is 0.67. Sorry, 6 into 0.67. So if you multiply 6 into 0.67, yes, so it's 5 trips per week. 230 by 23 into 2. It's not a container size, it's a vehicle size, 23. 23 into 2. Simply 10 by 2, 5. Average container size and container utilization factor. So be clarify with your things. This is container size and the container utilization factor. This is collection vehicle size and vehicle compaction ratio. Then the same question they are asking, time required per week, that is the TW. We have already calculated TW for all container system. Here we are going to calculate TW for stationary container system. The same formula with PSCS will change. There PHCS will be coming. Here PSCS. So if you see the formula, you can understand. Same TW formula, NW into PHCS plus S plus A BX by H into 1 minus W. Here, NW into PSC plus TW into S plus A plus BX, because there is no need to travel to the site every time. So here it will be separated and plus TW into. So NW we know, TW is the rounded off value by 8 into 1 minus W. So you can easily find the TW value in terms of X. Please write it down once in a notebook. You can easily understand what is the values. Yeah. So some of the theory questions we will go through. The time spent at site does not include pickup time, time spent unloading the waste from the container, time spent at the site during unloading. None of this. This is the at site time. That is S at site time. S value. S value does not include pickup time, time spent unloading the waste from the container, time spent at the site during unloading. Actually, C is the correct answer. Does not include, they are asking. S is equal to the time spent during unloading. No, the pickup time will not be included. pickup time is P. So pickup time is not included. You can see here, S is the time spent in unloading and also the time spent waiting to unload. So that and all will be included in S. But pickup time will be P. Okay. Please be clarified with this. And then what is the pickup time per trip in Hall container system? That is PHCS they are asking. Given that time required to pick up, that is pick up the container, PC they get given. Time required to drive between the containers, that is DBC they are given. Then time required to redeposit the empty container, that is UC they are given. So 12 plus 2 plus 3. It's actually answer is 17. Okay. It's simply Hall container system pickup time calculation. Answer is 17. Hope you got it. Next was, what is the length of the workday in a trip of a Hall container system? Number of trips they are given. Length of the workday is H. Usually we will take H as 8 hours, but here they are asking us to calculate the H with the given value. Number of trips ND they had given. Number of trips per day ND they had given. So H formula we know. ND equal to H into 1 minus W minus T1 plus T2 by THCS. THCS again we can calculate with the PHCS plus S plus H. Everything P given, S given, H given. So 3 addition will give you, a summation will give you that THCS value. Then T1 and T2 they given 0.13 and 0.18. W we know 15% or 0.15. Then H we can easily calculate by NDS 3. So answer is 5.4. So the easy problems you can use for Hall container system. So here a multiple choice question. What are the components included in the pickup time of Hall container system? Pickup time will be, now only I mentioned, picking up, unloading and distance traveled between. So here they are asking which component included. Picking up of the load container, off route time, at site time, redeposition of container after it has been emptied. So it's multiple option question. Multiple choice. Multiple choice. D is correct actually. A is also correct. So the answer is picking up and unloading and also the distance time required to travel between. So PC plus UC plus DBC. That's what. Okay. So pickup time they are asking. So A and D are correct. Okay. In which of the following transfer station the waste in the collection vehicle are emptied directly into the transfer vehicle? So smaller vehicle will come and directly it will unload to the bigger vehicle. Then it is called storage load, combined direct and discharge load, direct load, both storage and direct load. The answer is the waste the collection vehicle are emptied directly into the transfer station. Simple answer, direct load. Okay. Yeah. Then sixth question, which of the following transfer station is meant for multi-purpose facilities with the MRF? That is material recovery facility. Also there. Then it is called multi-purpose. Means something will unload and that will be segregated and some will directly load into the bigger vehicle, smaller vehicle to bigger vehicle. So it is multi-purpose. So both combined direct and discharge load. Yeah, correct. So seventh question, which of the following are features of transfer station? Features are advantage or disadvantage. Higher collection cost, high fuel and maintenance cost, low flexibility in disposal facility, opportunity to shred waste for disposal. All of this. Please check into it. Answer is features of transfer station. So we are constructing transfer station to reduce the collection cost. So first is not correct. No sir, not all the above. So transfer station will not increase the collection cost. It will only reduce. To reduce the collection cost only we are constructing transfer station. So it won't increase the fuel cost. And there is a flexibility for disposal option. As I mentioned, some may go to MRF, some may go to compost plant, some may go to landfills. So there is a flexibility to find the disposal option. There is no low flexibility, it's high flexibility. And then opportunity to shred the waste. That is the correct. So the answer is D. We can shred the waste in the transfer station and we can also bale in the sense compact and bale the waste. So the last question is, transfer station are used to dispose the waste to the disposal site in backyard collection system, transfer of solid waste from collection and other small to large transport equipment, all of this. Yeah, C is correct. Transfer of solid waste from collection and other small vehicle to larger transport systems. That's correct. Yeah. So thank you so much. If you have any doubt, you can ask me. I'll be online for next 2 minutes. If you have no doubts, you can leave the meet. Thank you so much. So today was more uh, problematic session. So again, I will take one more extra session to talk about some more problems in the Techno Banaglos books. We will see in some extra class. Thank you so much for joining. Hope you are enjoying the session. So the next 1 or 2 weeks will be like problematic session only. Yeah. Thank you. And
Thank you,
don't
sir.
forget to apply for the exam if you want certificate. 16th is the last date. I'll show you the course plan. I think the last date to register for the exam is 16th August. So if you need certificate, please register before 16th of August 2024. Yeah. And then don't forget to do the assignments on before every Wednesday. Okay. Thank you so much for joining. If you have no doubt, you
Thank you,
can
sir.
leave them. Yeah, thank you. Thank you.
Thank you, sir.
I'll end the meet. Thank you.